Yes, hello, how are you, everybody out there? Welcome to our first class, yes, online class in 2026, and I'm very grateful for those of you that have been following most of 2025, especially when we were building foundations of transformatics, and especially applying it using the transforming executable alphabet language. So talking of which, for those of you that have not yet picked up some of the literature and necessary material, we have this class that's very great for beginners, and I would love that you at least take a moment and check out some of the papers so that you can at least be able to attempt some of these problems and the kind of solutions that transformatics theory as a new branch or field of mathematics can enable us to accomplish. So talking of which, if you have looked at Transformatics 101, the mini thesis, we introduce first of all the 10 fundamental results that underlie that field, and then we have 10 proposals that actually help put into context some of the applications and how the other sciences, and mathematical sciences especially, can leverage transformatics. So as these ideas, for example, and related to statistical analysis or analysis of sequences, we have what is called the anagram distance. It's a new measure that I developed, and this is one of the very interesting things that we can use transformatics for, because this can be applied in any science, whether it is in chemistry, in biology, whether it's esoteric science, etc., even in the arts and even in economics. So for example, here we have two sequences there, and the first sequence has 5 elements and another sequence has 5 elements, and we are asked to try and analyze them. So in summary, there we see the first analysis there compares their cardinality, which is the size or length of those sequences, and their equivalent. The next one looks at the symbol set. What are the unique elements in each of those sequences in the order in which they appear. So there we have the first one and the second one. And then when we look at the symbol set, what is called the natural symbol set in a base. So in the base A to Z, you see that they have the same symbol set in the base A to Z or in the Latin alphabet, whereas they have two different symbol sets. And then we see that these sequences are not equivalent, because when you compare them there, item by item, they're not equivalent. And then also we see this here is a claim that maybe someone will work out, but it's a claim that their anagram distance is not 0, meaning they're not equivalent. Okay, this is actually a consequence of that, because the theory of anagram distance tells us that if two sequences are similar, then the anagram distance is 0. If it is less than or equal to 1, they are maybe approximately similar, and if it's greater than 1, they are really dissimilar. So one of the interesting things about this tells us that, for example, if you took some of these items in sequence 1 and you shifted each of them by maybe 1 position, most likely you're going to end up with anagram distance that's greater than 1. So how do we arrive at that measure? So we see that it is a ratio that takes into consideration the absolute distance between the position of the elements in either sequence, in the original sequence and in the final or resultant sequence. And we are looking at absolute. So when you take those differences there, you'll find that actually just summing up those absolute differences, and then computing a ratio with the cardinality of either the original or the resultant, you'll arrive at a measure which is a real number that will tell us how different or how far apart they are. So that's it. And hopefully you look at some of that theory, learn a lot of it. It's very applicable. We are applying it in genetics, which is the science, the biological science that looks at how life originates from DNA or nucleic acids. So this is the biology underlying everything, every living thing and even medicine and other fields of science can derive from that. So look forward to that. The book is coming out this year, 2026, and hopefully you'll be able to enjoy seeing how research at Nuchwezi and some of the work we've done at Makerere University might underlie the future of science and mathematics in many fields. So that's it. Future Prof. See you.